The New Zealand Refining Company owns and operates New Zealand's only oil refinery at Marsden Point near Whangarei. This is the story of the Future Fuels project, the biggest expansion project of the company for more than 25 years. The refinery has been processing fuel for New Zealand since 1964 and provides the country with 80% of its diesel needs and 70% of its petrol needs. A major expansion in 1983 saw a $1.8 billion investment in new plant and equipment. This huge revamp was required to increase the efficiency of the refinery and provide the extra products required by a growing nation. In 2002, the government announced new fuel quality regulations that would bring New Zealand fuels to a standard now required in other countries such as Europe, America, and Australia. The new specifications will apply to all diesel and petrol sold in New Zealand. They're aimed at improving air quality by reducing vehicle emissions into the atmosphere. They'll also allow the use of advanced engine technologies, offering the benefits of further emission reduction and greater fuel efficiency. The government announced that the level of sulphur in diesel would drop in 2 stages from 3,000 parts per million down to 50 parts per million by the 1st of January 2006. The regulations also contained a provision to reduce the diesel sulphur content further to 10 to 15 parts per million by 2009 at the latest. Benzene levels in petrol would also drop in 2 stages, down to less than 1% by January 1st, 2006. The announcement of the new regulations posed a serious problem for the refinery. The existing plant and equipment was unable to produce fuel at the quality specifications required. The company faced a serious threat to its ongoing refining operation. The CEO, Dr. Thomas Singley, explains.
One has to understand in which situation the company was in 2001 and 2002. We knew exactly that we had to spend a lot of money to be able to produce the new specifications here at Marsden Point. An investment of about $150 to $200 million. That was pretty clear at that time. It was also clear that this investment would not provide shareholders with a good return. So this was one of those situations where you have to make up your mind whether you want to stay in business or not. One also has to remember that the 1990s were a very difficult period for refineries across the globe. There was too much capacity everywhere, cost pressures were mounting, and several refineries had to close because they were unprofitable. It is understandable that in this environment, the board of directors of NZRC was not really keen to spend a lot of money with an uncertain return in a medium-sized refinery in a market which is relatively small. There was another challenge coming upon us, and these were the Kyoto policies of the New Zealand government. It was announced that at a certain time in the future, a carbon tax would be introduced in New Zealand. And that would mean for the refinery an additional cost of up to $25 million per year. This is the same amount that we pay out every year on our entire payroll. No other refinery in the region was exposed to such a threat. So the challenge was pretty clear. On the one hand, we had to convince our board that it was worthwhile to spend the money needed in this place to keep the refinery going. And secondly, we had to engage government to avoid the threat of a carbon tax coming upon us before our competitors would be exposed to the same tax.
Following several product quality studies done since 1998, the board of NZRC approved a budget of $8 million. This was used to define the scope and a cost estimate of a project that would cope with the new specifications. A small team was set up to begin the huge task of putting all the pieces in place for this complex project. They put detailed plans in place for the building of a plant that meets the new specs. These plans included project financing, technology licensing, and selection of the contractor who was going to build the plant. Another team was formed to begin negotiations with the government on greenhouse gas emissions. This resulted in the country's first negotiated greenhouse gas agreement, exempting the company from the government's planned carbon tax and committing it to follow a pathway defining world best practice in energy management. By early 2003, management of NZRC presented their plans to the board. With the signing of the negotiated greenhouse gas agreement, the board approved the spending of $180 million to build the new plant. The Future Fuels project, as it became known, would require the construction of a new hydrogen desulfurization unit to lower the sulfur in diesel, a benzene removal unit to lower the benzene in petrol, and a hydrogen separation unit to provide the extra hydrogen required by the new units. Manager of Process Services, Rex Passau, explains how the new plants will work.
Crude oil contains sulfur. It's a naturally occurring component. In refineries, when they start to make fuels, begin to separate the crude into different fractions. Those fractions go on to be made into the fuels: petrol, kerosene to make jet fuel, gas oil to make diesel, and heavy fuel oils. As we separate out each fraction, the sulfur that's naturally occurring in the crude oil comes with it. In the case of diesel, we get a significant amount of sulfur in the raw diesel that's been extracted from the crude. The sulfur is bound into the molecules that make up the diesel. And in the case of the hydrodesulfurizer, we use that unit to remove the sulfur from the molecules that make up the diesel. Raw diesel containing sulfur is pumped in from the tank farm to the hydrodesulfurization unit. The diesel, as it comes in, is mixed with hydrogen and then goes through a process where it is heated up and then onto a furnace, where we fire large amounts of gas to heat the material further. The diesel and the hot hydrogen gas then go into the reactor, which contains 140 tonnes of catalyst. The catalyst is an unusual mixture of ceramic and nickel and molybdenum. In that reactor, we break open the diesel molecules and extract the sulfur, turning the sulfur into hydrogen sulfide gas. The desulfurized diesel, hydrogen sulfide gas, and hot hydrogen exit the reactor and flow on out through some separation processes where the hydrogen sulfide is removed, the hydrogen is returned back to the hydrodesulfurizer, and the diesel is then clean desulfurized diesel is then pumped to storage for blending into diesel. Crude oil also contains benzene. When a refinery goes to make petrol, it extracts a component called naphtha from crude oil, and all of the benzene in the crude oil goes into the naphtha. Naphtha itself cannot be used to make petrol. It has not got the right properties. The refinery further converts the naphtha into a component that is good for blending into petrol. Unfortunately, as a side product of that, a lot more additional benzene is made. As benzene is a hazard to human health, the refining company has built a unit to destroy the benzene in this stream. The stream of petrol component containing a large amount of benzene is brought into the benzene removal unit. Here it is separated into a heavier stream which can be sent straight away to blending, which contains no benzene, and a light stream which contains all of the benzene. This stream is then mixed with hydrogen, heated up, and sent to a special reactor containing 6 tonnes of catalyst with a lot of platinum on it to make the reaction occur. The benzene in that reactor is destroyed by mixing with the hydrogen. The material that exits the bottom of the reactor is further separated, and the hydrogen that's not been consumed is recycled, and the component that's left, the life naphtha with no benzene, is sent away to blending to be turned into petrol. Both of the main processes in the Future Fuels project consume large amounts of hydrogen. The refinery has a large gas stream with a high concentration of hydrogen in it. The concentration of hydrogen is not of sufficient purity to use directly in the new Future Fuels process units. As a result, a special hydrogen separation unit has been built. It consists of large steel vessels containing a special membrane. The hydrogen-rich gas is brought into the steel vessels onto this side of the membrane. The hydrogen in the gas can go inside work its way through this membrane, which works like a filter, travel down these little tubes and out the bottom, and to be sent away as pure hydrogen to be used in the Future Fuels processes. The gas that is left can be sent off to be used as fuel or to be itself converted into hydrogen.
With the refinery's future assured, no time could be wasted. Foster Wheeler were the chosen contractor. They began work immediately on the huge task of assembling the workforce required to undertake this large project. A small village sprang up on vacant land near the site to provide offices and facilities for the workforce. Soon this small huddle of huts had grown into a bustling community. The refinery prides itself on its safety record and sets very high standards of safe working practices for its workforce. It was imperative that these high standards were maintained throughout the construction of the new plant. Long before construction started, a robust safety plan was developed. An induction system was put in place to explain to the workforce the safety requirements for working on the site. No one was allowed to work on the construction team unless they'd been through the induction process. Safety Manager Guy Buffy explains.
The construction of the Future Fuels project commenced in August 2003 and will be completed in August 2005. During this time, the project inducted 1,500 workers with a peak of 700 during construction activity. The project itself and the safety team have worked continuously to improve the safety culture of the project. This has been achieved by a disciplined team approach with all the main contractors and a no-blame culture. An open, honest reporting approach was applied, where near misses and findings from a safe visiting programme were proactively communicated and actioned. Early in the execution, we established a partnership agreement with OSH, who have supported our approach and performed timely audits. Engagement of the workforce was recognised as a key foundation in establishing the right safety culture for the project. This was a significant task when considering the majority of the workforce had never worked within an operating refinery before. The integrated team developed safety initiatives including benefits and contributions to local charities, Manu Health Club, Bream Bay Swimming Centre and Rukaka Lifesaving. Celebrations of safety performance by the presentation of shields and certificates for best safety practice were issued each month. We have recognised safety at all levels, the individual, the team and the contractor. Considerable effort has been given to develop the behavioural aspects of individual workers by training, interaction, engagement, safe visiting and hazard spotting techniques.
Construction work on the new plant began in February 2003. The first job was the removal of a large oil tank to make way for the new plant. This tricky task was safely undertaken by first filling the tank with water to give it more stability, then removing small sections of the tank at a time, gradually lowering the level of the water in the tank until ground level was reached. With a clear site, construction proper could begin, and site foundations and civil work was soon underway. Because of the short construction time that was required, the project team had decided that the plant would be constructed of pre-built modules that would be built elsewhere. These would then be delivered to the refinery, ready to be mounted onto the foundations. This would greatly speed up the building process and require less construction staff on the site. The modules were built in Thailand under the supervision of Foster Wheeler International. A team of Thai engineers were soon hard at work in Sriracha, designing and building the pre-built modules. A special computer-based model was developed, and this was used to assist the design and construction process. Project manager Tom Lopnow explains.
The idea of the modules, Foster Wheeler has done this before in several other units. I personally have done it on another project here in New Zealand. The modules take man-hours away from the field, put them into places like shipyards, where this was done in Thailand. And it gives you a quick parallel construction. While we were putting in foundations, they were building the modules, where typically in a normal construction you would build the foundations and then build off of those modules. Here they were both done simultaneously. And when the modules arrived, foundations were done, they were set, and you have instant progress really, because you've done things in parallel. It helps expedite the project, and in this case also helped on the cost side because of the Thai yards being less expensive.
Work continued on the site in readiness for the arrival of the modules. The foundations were poured and the heavy concrete structures required to hold the modules began to appear all over the site. In Thailand, the modules were all completed. At the port of Lam Chabang, they were lined up ready to be loaded onto the ship that would transport them to New Zealand. The Happy Buccaneer was a purpose-built ship designed to carry and transport heavy loads of up to 35,000 tons. She'd already loaded the new HDS reactor in Japan and some heat exchanger equipment in Indonesia. Her 2 giant cranes were soon in action, loading the rest of the cargo in Thailand. The first to be loaded onto the ship were the columns and reactors for the new units. Due to the size of the structures and the delicate maneuvering required to lower them into the hold of the ship, the work was slow and painstaking. Piece by piece, the work continued until the hold of the ship was full of the large and heavy equipment. Then it was the turn of the giant pipe rack modules to be loaded onto the deck of the ship. Once the ship was fully loaded, she set sail for New Zealand, where the construction team were anxiously waiting. At the construction site, all was ready for the arrival of the modules. A giant crane had arrived on site. It was one of the biggest cranes ever seen in New Zealand and was capable of lifting loads of over 300 tons. On the 20th of September 2004, the Happy Buccaneer docked at the Northport jetty close to the refinery and began unloading her precious cargo. First to come off the ship were the pipe rack modules. These were followed by the columns and reactors. The massive pieces of equipment were loaded one by one onto special trailers. Slowly they inched their way from the port to the refinery. The first task was to lift the pipe rack modules into position. The giant crane swung into action and began the delicate task of lifting the heavy modules into place. One after the other, they were lifted onto their foundations by the crane. The teams of riggers pulled and tugged until the pipes in the adjoining modules were exactly in line. Such was the accuracy of the construction that all the modules lined up perfectly. It was then the turn of the columns and reactors to be lifted into place. With infinite care, they were slowly lowered into their foundations and bolted into position. The skill of the design and construction team was again evident as they all fitted into their foundations exactly. Like a giant construction set, the project took shape, and soon the refinery skyline was changed forever. By the start of 2005, the final phase of construction was underway, as teams of workers began turning the jumble of pipes and equipment into a finished plant. Welders began joining up the pipes on the modules. Cables were laid to provide power for the pumps and equipment and electronic signals for the complex instrumentation systems. Engineers began installation of the pumps and compressors. Scaffolding sprang up like a spider's web over the whole plant to allow the construction team to work safely at high levels. Everything was on track to complete the project by August 2005. As the plant neared completion, Foster Wheeler Field Superintendent Ian McFarlane looked back on the project.
The construction challenge for Foster Wheeler has been a logistical problem where, in terms of we modularised and supplied the spools in offshore, i.e. in Thailand. Getting everything here during the heavy lift programme to meet the heavy lift programme was a success, and the commissioning driven schedule has provided challenges that's has taken us a long way to delivering on time in the time scale that NZRC provided. It's been a pleasure for Foster Wheeler working on this job, and we look forward to a continued success with NZRC.
Training is a priority on all projects. It's the construction team's job to build the plant, then hand the completed project over to the refinery staff who will be operating and maintaining the new units. Throughout the project, the focus has been on ensuring that the handover would be as smooth as possible. At a very early stage in the construction, a dedicated team of operators were assigned to the site. It was their job to familiarise themselves with the new units and to provide operational advice and help to the construction team. These operators and a team of trainers arranged in-house training courses for the many trade disciplines in the refinery. This was to ensure that all involved would have a full understanding of the startup and ongoing operation of the new units. During the startup phase, each line and piece of equipment was checked and double-checked. Everything ticked off on checklists to ensure that nothing had been forgotten. Only then could the new plant be livened up. Steam, nitrogen, water, fuel and oil products, the very lifeblood of a refinery, all began to flow into the pipes and vessels of the new units. The Future Fuels project was ready for startup.
Copy D block. You guys, we have confirmation from off plots. Booster pumps are online and we can open the main feed valves to HTS3 and the BRU. Okay guys, yeah, we now have feed into the unit and we have a rising level in our surge drum. We can stand by to start the main feed pump. Looking good fellas, start fresh gas machine. Copy D block. Okay guys, can we please start the furnace? Yep, D block. We can confirm now rising temperature in the reactor. Stand by to switch on overhead cooling fans. Gentlemen, reactor temperatures are now at normal running conditions. We are making low sulphur diesel. You guys, we have a rising level in the splitter. Can I have someone confirm that level for me, please? Guys, thank you for that. We now have feed to the reactor, the BRU. Okay guys, we have full reaction temperature reached in the BRU. And we can confirm benzene reduction has started. D-block operators, can we sample our products please and have them sent to the lab for testing? D-block, lab results confirm all products are on grade. Can we now switch our rundowns please to tankage? Panel to tank farm operators. The Future Fuels are now blended guys and on grade ready for delivery. Off plots, can we open up tank sides to pipeline and to jetty please?
Hello panel, pipeline reset and ready for startup.
It's well done everyone. All products are on spec and delivered to the customer.
This completes the remarkable story of the Future Fuels project. Born by the desire to improve the air quality in the country, the new legislation provided the New Zealand refining company with a major challenge for survival. The team at NZRC rose to the challenge. They conceived, planned and implemented the biggest project undertaken at the refinery in over 25 years, providing the foundation for its own future of continued and expanding operation. Thomas Sengeli sums it up.
We had many challenges to address and many issues to solve during the project. The team has managed to solve all problems as they came along. They did a fantastic job. 3 years ago, they said that they would be ready in August and September 2005, and they delivered. They also said that they would implement the project in a safe way, without incidents. And they delivered. And last but not least, they said that they would have to spend about $180 million on the way. And they delivered again. This shows that we can implement a major project at NZRC successfully. I thank everybody who has participated in this team effort. Well done. And I'm looking forward to the next major project at Marsden Point.